This is not normal transportation. These machines move submarines, power plants, and giants weighing thousands of tons. Every turn is calculated. Every mistake costs millions.
This is not just a machine being moved. This is a submarine, the German Navy's U17 U-Boot, weighing over 500 tons and stretching close to 50 meters in length. To understand its scale, imagine transporting something longer than a blue whale and heavier than 100 fully loaded trucks, not through the ocean, but across city roads. When operational, a submarine like U-17 costs well over $200 million US, packed with military-grade steel, sonar systems, pressure-resistant hulls, and decades of naval engineering. The real challenge isn't just weight, but balance. One wrong tilt and internal structures worth millions could be damaged. Moving this submarine required extreme precision, multi-axle transporters, and routes planned down to the smallest turn. It's like relocating a steel predator of the deep through human civilization. This transport proves that heavy haulage isn't just about strength, it's about respect for physics, history, and engineering perfection. What you are watching here is global industry on the move. The Long Sun A1 Olefins plant project, executed by deugro, involved transporting refinery modules so massive they look like space station components placed on wheels. Each module weighs hundreds to thousands of tons, with lengths comparable to a Boeing 747 and heights taller than a 4-story building. These modules are pre-assembled industrial giants designed to save years of construction time once they reach the plant site. The value of a single transported unit can easily exceed 50 to 100 million US, making every meter of movement critical. deugro specializes in project logistics, meaning bridges are reinforced, roads modified, and ports re-engineered just to allow passage. This is not transport for speed. This is transport for absolute precision, where one move can define the success of an entire industrial project. This is Stavridis S.A, a company known for handling some of Europe's most demanding heavy transport operations. Their cargo includes massive transformers, turbines, ship sections, and industrial components weighing 600 to over 1,000 tons. To put that into perspective, that's equivalent to moving 150 African elephants together as a single load. These transports rely on advanced hydraulic multi-axle trailers that distribute weight so evenly that even older bridges can survive the crossing. A complete heavy transport configuration like this can cost 5 to 10 million US, excluding planning and route preparation. What makes Stavridis remarkable isn't brute force alone, it's controlled movement, centimeter by centimeter over long distances. This is engineering discipline at its highest level, where patience and precision matter more than speed. When something is too big, too heavy, or too complex for anyone else, the call goes to Mammoet. This legendary heavy transport and lifting company has moved loads exceeding 20,000 tons, heavier than 3 Eiffel Towers combined. Their self-propelled modular transporters can move enormous structures sideways, rotate them in place, and lift them hydraulically as if gravity were optional. A single Mammoet operation can cost tens of millions of dollars, but the alternative is often impossible. Founded in the Netherlands, Mammoet's elephant logo perfectly represents their approach. Slow, intelligent, unstoppable power. From oil platforms to nuclear components, Mammoet doesn't just transport machines, it relocates entire pieces of civilization. If humanity ever decides to move a mountain, Mammoet would already be calculating the route. This is Goldhofer engineering at its finest. The THP SLL and THP ST modular transport systems. These trailers are designed to carry extreme loads ranging from wind turbine components to refinery reactors weighing several thousand tons. Each axle line is hydraulically suspended, allowing the load to remain level even on uneven terrain, sharp turns, or steep gradients. A fully configured Goldhofer modular setup can cost several million US, but it delivers unmatched stability and flexibility. In size comparison, a fully extended Goldhofer configuration can be as long as a football field, yet still maneuver through tight industrial corridors. What makes these machines special is their modularity. Axles can be added or removed like building blocks, adapting to almost any challenge. This is not just a trailer, it is a mobile foundation built to carry the heaviest ambitions of modern engineering. This is the Volvo FH16 780, the most powerful production truck Volvo has ever built, and a true predator in the world of heavy haulage. Under the cab sits a 780 horsepower, 16-liter engine, producing up to 3,800 Nm of torque, enough twisting force to pull loads weighing 250 tons or more depending on configuration. That torque is stronger than what some small ships produce. The price of a fully equipped FH16 Heavy Transport Edition can cost $250,000 to $300,000 US, and every dollar goes into strength, reliability, and control. Ravago Cranes Philippines operates in one of the most challenging environments on Earth: tight urban areas, soft ground, and coastal industrial zones. Their heavy transport operations involve moving massive construction components, generators, and industrial modules weighing hundreds of tons. The equipment used in these jobs, including heavy cranes and multi-axle transporters, can collectively represent an investment of tens of millions of US dollars. To visualize the scale, some of these loads are heavier than a fully loaded Airbus A320. What makes Ravago impressive is adaptability. Every transport is customized to local conditions, from road strength to weather and terrain. In regions where infrastructure is limited, precision and planning matter more than brute force. This is heavy transport under pressure, where engineering meets real-world constraints, and failure is never an option. This machine looks futuristic, and it is. The SCHEUERLE Rotor Blade Adapter G4 is designed to transport wind turbine blades measuring up to 85 meters long, longer than a Boeing 737 wingspan. Mounted on multi-axle trailers, this system can lift blades hydraulically and tilt them up to 60 degrees, allowing operators to navigate tight mountain roads, steep gradients, and narrow village streets. A full rotor blade transport setup like this can cost several million US dollars, but it saves entire forests from being cut just to widen roads. In real operations, these systems have climbed slopes of 17%, maneuvering blades like a surgeon handling a scalpel. Watching it work feels unreal. A giant wing floating above the road, bending to human infrastructure. This is not transport. This is engineering diplomacy between nature and industry. This is the Liebherr LR 13,000, the largest crawler crane ever built. When fully assembled, it can lift 3,000 tons, equivalent to lifting 6 fully loaded Boeing Y-747s at once. The machine itself weighs over 3,000 tons and assembling it requires dozens of trucks just to deliver its components. The price of this monster exceeds $20 million US, depending on configuration. Its boom can rise higher than a 30-story building, dominating the skyline like a mechanical dinosaur. Despite its size, the LR 13000 moves with incredible smoothness, using advanced load monitoring and stability systems to keep everything under control. This crane exists because modern industry demands the impossible, and Liebherr answered by building something that redefines the limits of lifting. This is the Rheinmetall High Mobility Truck System, a military-grade heavy transport platform designed to operate where roads barely exist. Built for extreme logistics and battlefield supply, these trucks can carry payloads exceeding 15 to 20 tons off-road, while towing far more on specialized trailers. Powered by engines producing 440 to over 540 horsepower, these trucks are engineered for torque, not speed, allowing them to climb rough terrain that would stop civilian vehicles instantly. A single Rheinmetall HX truck can cost $400,000 to over $700,000 US, depending on armor and configuration. To put its strength into perspective, this truck can operate in environments where even tracked vehicles struggle. With central tire inflation, reinforced frames, and military suspension, it's like a mechanical camel, built to survive deserts, mud, snow, and war zones. This system proves that heavy transport isn't always about size. Sometimes it's about surviving where nothing else can move. The SCHEUERLE EuroCompact is built for one mission, moving massive loads through tight European infrastructure. These modular trailers are capable of carrying hundreds to thousands of tons while remaining compact enough to pass through narrow streets, sharp corners, and restricted industrial zones. A fully equipped EuroCompact configuration can cost several million US, but offers unmatched maneuverability and stability. Each axle line is hydraulically controlled, allowing the load to stay perfectly level, even on uneven roads. Compared to traditional heavy trailers, EuroCompact feels like a scalpel instead of a hammer. These systems are often used to transport transformers and reactors heavier than a fully loaded passenger train carriage. This is heavy transport designed not just for strength, but for elegance under pressure. This is a Scania heavy haul unit built to pull loads most trucks wouldn't even attempt. With engines producing up to 770 horsepower and massive torque output, these trucks are capable of hauling 200 tons or more when paired with specialized trailers. A fully configured Scania heavy haul truck can cost $250,000 to $350,000 US, depending on drivetrain and reinforcement options. What sets Scania apart is drivability. Even under extreme load, the truck feels controlled and predictable. Compared to standard trucks, it's like comparing a locomotive to a family car. Scania's reputation in heavy haul comes from decades of real-world testing in mining, forestry, and extreme transport environments. This is not about raw aggression, it's about refined, reliable power that never gives up. This is the Sarens KAMAG SPMT 6-axle New Gen, a self-propelled modular transporter designed to move loads that seem completely immovable. Each axle line can support up to 36 tons, meaning a 6-axle unit can carry over 200 tons, and multiple units can be combined to transport loads weighing thousands of tons. The price of a single SPMT unit can exceed 1.5 to 2 million US dollars, and a full fleet represents massive investment. These machines can move sideways, rotate on the spot, and climb gentle slopes while fully loaded. Watching an SPMT work feels like watching a building walk. Sarens uses these machines to move bridges, offshore modules, and entire industrial structures. This is heavy transport taken to a level where wheels replace foundations. This is Goldhofer ADDRIVE, where heavy transport meets intelligent mobility. ADDRIVE equipped trailers use electric wheel motors powered by diesel generators, allowing them to move independently without a traditional tractor. These systems can carry hundreds of tons while maneuvering in tight spaces like ports, factories, and shipyards. A complete ADDRIVE setup can cost several million US dollars, but it delivers precision that conventional trailers cannot match. Compared to normal transport, it's like the difference between pushing an object and having it walk on its own. ADDRIVE allows synchronized steering, perfect traction control, and extreme maneuverability under load. This technology is redefining how the heaviest objects on Earth are moved, slowly, silently, and with absolute control. This is Graham Group, a name trusted when industrial cargo becomes too large, too heavy, or too complex for standard logistics. Graham handles oversized modules, heavy plant equipment, and infrastructure components weighing hundreds to thousands of tons. These transports often involve cargo longer than a football field and heavier than multiple passenger aircraft combined. A single heavy transport operation managed by Graham can be valued at tens of millions of US dollars, considering engineering studies, route preparation, and execution. What makes Graham stand out is integration. Lifting, transport, and installation are planned as one continuous operation. Watching their projects feels like witnessing an entire factory relocate itself. This is logistics at a scale where mistakes are not corrected. They are prevented long before the wheels start moving. This is Nooteboom, one of Europe's most respected heavy trailer manufacturers. Their trailers are built to transport extreme loads such as transformers, turbines, and industrial modules, weighing up to several hundred tons. Depending on configuration, a Nooteboom heavy transport trailer can cost $500,000 to over $2 million US dollars. Known for low bed designs and advanced steering systems, Nooteboom trailers allow massive cargo to pass under bridges and through tight curves that seem impossible. Compared to standard trailers, these machines are like flattened tanks, engineered for stability rather than speed. For decades, Nooteboom has played a key role in shaping how heavy transport moves through Europe's dense infrastructure. This is not just a trailer, it is a carefully balanced engineering platform designed to carry modern industry. Wind blade transport represents one of the most challenging tasks in heavy logistics. Modern turbine blades now exceed 80 meters in length, longer than a Boeing 737 fuselage, yet far more delicate. These blades may weigh only 20 to 30 tons, but their length, flexibility, and wind sensitivity make them extremely difficult to move. A single blade can be worth hundreds of thousands of dollars, and a full turbine set represents millions. Specialized trailers with lift and steer technology allow blades to twist, tilt, and bend through mountain roads, villages, and forest paths. Watching this transport feels unreal, like carrying a giant feather through a maze of concrete. This operation proves that in heavy transport, difficulty isn't always about weight. Sometimes it's about shape and control. The Montejo mining project showcases what heavy transport looks like in the rawest conditions. Massive mining equipment components weighing hundreds of tons are transported across rough terrain, undeveloped roads, and remote project sites. These loads can be heavier than entire passenger trains, yet must arrive perfectly aligned and undamaged. The cost of mining transport operations can reach tens of millions of US dollars, because every delay means lost production. What makes mining logistics unique is endurance. Machines must operate continuously under dust, heat, and extreme loads. This is heavy transport at the edge of civilization, where engineering solutions replace infrastructure. Watching these operations feels like witnessing industrial survival in action. This is the Faymonville CombiMAX, a modular heavy transport trailer system designed to adapt to almost any load. With axle loads capable of supporting hundreds of tons, CombiMAX configurations can be extended, widened, or reinforced depending on the challenge. A fully configured CombiMAX system can cost several million US dollars, but it offers unmatched flexibility. Compared to fixed trailers, CombiMAX behaves like industrial Lego, building the perfect platform for each job. These systems are used worldwide to transport generators, turbines, and refinery equipment through environments where millimeters matter.
If moving mountains had wheels, this is what it would look like. From record-breaking loads to machines that defy physics, this is heavy transport at its extreme. If this blew your mind, hit like, subscribe, and stay with Mighty Machine. Because the biggest machines on Earth are still on the way.